In this video, we are going to finish out filling out the unit circle. We've already filled in the radians and degrees, so make sure you watch that previous video if you haven't yet. But now we're going to fill out these points that are on the perimeter. And what we need to know first is we need to have some prior knowledge about special right triangles, or nothing in this video is going to make sense. So for special right triangles, we have two special rights. We have the 45-45-90 and the 30-60-90. And this is the relationship between the side lengths. For a 45-45-90, if you know the leg lengths, you multiply by the root of 2 to find the hypotenuse. If you know the hypotenuse, you divide by the root of 2 to find the leg length. And then we have some similar relationships over here with the 30-60-90. If you know the short leg, you double it to find the hypotenuse. If you know the hypotenuse, you divide it by 2 to find the short leg. And then if you know the short leg, you multiply by the root of 3 to find the long leg. And if you know the long leg, you divide by the root of 3 to find the short leg. So this is prior knowledge that you will need to know in order to understand what we're doing here. If you don't follow this, you need to go watch a few videos on special right triangles first. Now, what we're going to do is we're going to take our knowledge of special right triangles and translate it to when the hypotenuse is 1. So as we discussed, if you know the hypotenuse of a 45-45-90, you divide by the root of 2 to find the leg length. So if my hypotenuse was 1, in order to find x, I would divide 1 by the root of 2. And then we'd have to rationalize that by multiplying by root 2 over root 2, because we're not really supposed to leave a root of 2 in our denominator. So when you multiply straight across, 1 times root 2 is root 2, and then in my denominator, root 2 times root 2 is root 4, and the root of 4 is 2. Well, the good news is finding y will be the same process, because to find this leg, you would take the hypotenuse and you would divide by the root of 2. So we could show this math again, but it's not really necessary because we're going to find that if the hypotenuse is 1, both of these legs, since they're congruent, will have a length of root 2 over 2. Now let's do the same thing for our 30-60-90. We came over here and we said if you know the hypotenuse, you can divide by the root of, or excuse me, you can divide by 2 to find the short leg. So if you know the hypotenuse, you can divide by 2 to find the short leg. So if you take the hypotenuse and you divide by 2, that's all you got to do. Our short leg here has a length of 1/2. If you know the short leg, you can multiply by the root of 3 to find the long leg. So if you know the short leg, which is 1/2, you can multiply by the root of 3 to find the long leg, and you find that the long leg has a length of root 3 over 2. I summarize this on our next slide. So these are relationships that we need to know. For a 45-45-90, we know that the legs will have a length of root 2 over 2 if the hypotenuse has a length of 1. And in a 30-60-90, we know that our short leg will be 1/2 and our long leg, will be root 3 over 2 if the hypotenuse is 1. Now, here's another idea. I just want us to think about taking these triangles and imposing them onto a coordinate plane. So for example, let's say we have this blue triangle that has a length of 3 and a length of 2. Where would point A be if I centered it here with this being the origin? And you might think, okay, well, if this goes 3 units to the right and this goes 2 units up, then this point A right here will be 3, 2. And then we can use the same reasoning for this triangle and find the location of point B. Because if this has a length of 4 and a length of 4, well, if this is the origin, it looks like we go to the left 4 and up 4. Now, you got to be a little bit careful, because if we went to the left 4, that means this would be negative 4, 4. And then lastly, I realize none of this is drawn to scale, but if we have this little triangle C with a leg length of 1/2 and a leg length of root 3, then we know that this point C right here, you got to be careful, we're in the third quadrant, so it's going to be negative 0.5 or negative 1/2 and negative root 3. Okay? So I've just made up links to illustrate an idea here. So don't, I just want you to kind of understand that, because now we're going to combine our two ideas together. So if I come back to this unit circle, and once again, we derived these angles and these radian measures in a previous video, let's take these triangles and put them on the unit circle. So I'm going to start with this 45-45-90. If I were to take that triangle and I were to put it here, and we know that our radius is 1, this is our triangle. I'm going to try to shade it in right here. Maybe actually using a red highlighter would look a little bit better. So here is our 45-45-90. We derived these leg lengths on a previous slide. So if we go to the right root 2 over 2 and up root 2 over 2, then this is going to have a location of root 2 over 2, comma, root 2 over 2. And we can do the same thing with this other triangle. Let's take our 30, 60, 90, and I'll kind of show this in blue right here. If we take a 60-degree angle up to this point with a hypotenuse of 1, and we come down so that our triangle is superimposed onto our unit circle, we'd find that we went to the right half a unit and up root 3 over 2. So if I went to the right half a unit, that would be our x-coordinate. And if I went up root 3 over 2, that would be our y-coordinate. So 1/2 root 3 over 2. And then you might have kind of connected this on your own. I'll use orange for this. This point right here, this is a 30-degree angle. I've kind of covered up my angle right there. But we could use this same triangle. So if I take this same thing, and it's still a 30, 60, 90, we're just going to drop this onto our unit circle here, but I just went to the right root 3 over 2, and then I only went up 1/2. So it's going to be this. It's going to be root 3 over 2, 1/2. So by using these special right triangles and plopping them down right on the middle of our unit circle, we can find these coordinates, these odd little irrational coordinates. I guess we got a couple of rational numbers that are on our unit circle. And these are the 3 points we need to know. And really this process is just going to repeat because we've now found these points, but these are going to have the same relationship. I could put my special right triangles here and find these points, or you could just think of it this way. Think about this 135 right here. It's opposite to 45. It has the same y-coordinate, doesn't it? It'll have the same y-coordinate at this point. And it's the same distance to the left. It would just have a negative x-coordinate. So I want you to maybe pause the video and see if you can fill out these 3 points in the second quadrant. These will have a negative x and a positive y. Fill out these 3 points in the third quadrant. They'll have a negative x and a negative y. And then fill out these 3 points in the fourth quadrant. They'll have a positive x and a negative y. And boom, that's what your unit circle should look like when it's completely filled out. I'm actually going to show you another video where I show you kind of a shortcut to help you memorize some of these points. Because often you might have a question that says, hey, fill out a unit circle, and it's on a quiz. And that took a while, what we just did. So I want you to be able to do this quickly. So I'm going to show you another video that kind of has a little bit of a trick involved there.